Okay, so here's section 4.7 notes. So the topic, section 4.7, essential question, how to use the base angles theorem to find angle measures in a triangle. So whenever you need to pause so that you can take time to write things, go ahead and do that. I won't tell you each time when you need to pause. All right, so our only main idea today is we're going to focus on isosceles triangles. And so that's our main idea, isosceles triangles. And the first thing we're going to talk about are parts of an isosceles triangle. And remember the definition of that said that it has at least two congruent sides. So we had to talk about how equilateral triangles are also considered isosceles because of the definition of isosceles triangle. And now this picture here, I'm going to refer back to this as some examples of the different parts. So we've got four parts of an isosceles triangle that you need to know. The first one are what the legs are, and the legs are the two congruent sides. So parts of an isosceles triangle, when you have two congruent sides, the legs are those two congruent sides. So in my picture, that would be segment AB and segment AC. So there may be a question, hint, hint, where I will give you a picture and I will ask you to list the legs. So those are segments, so give me the two segments that are congruent to each other. The next thing will be the base, and the base is the non-congruent side of the triangle. So the guy that's not congruent, he is considered the base. Now the base won't always be the horizontal piece, so don't think that that's always the case. This could be flipped on its side or upside down. So the base is whichever side's left over that is not congruent. So in this case, this will be segment BC. Okay, the vertex angle is where the two congruent sides meet. So if they ask you to list the vertex of the triangle, it's going to be where the two congruent sides meet. So in my picture here, angle A is going to be the vertex angle. And then the last piece are the base angles. And the base angles are the two angles that are touching the base of the triangle. So notice we had segment BC. So then that means angle B and angle C are the base angles. So the base angles are the two angles that are touching the base of the triangle. So it's basically those two endpoints of the base of the triangle. Okay. Now, if it's an equilateral triangle, then you can't decipher all of this information. So I wouldn't give you a picture of an equilateral triangle because that is considered isosceles still, and ask you to list all of these items. Okay. So it would only be if I give you two congruent sided isosceles triangle, then again, that's not for you, it's for lunch. And then you can list those things, but in an equilateral triangle, you could not. Okay, so there's two theorems that we need to talk about. The first one is called the base angles theorem, and this is still part of the main idea of isosceles triangles. It's not a new main idea. So base angles theorem says if two sides of a triangle are congruent, then the angles opposite them are congruent. And those angles are actually the base angles of the triangle. So if it's given to us that we have an isosceles triangle, so I've got two congruent sides here, then what this theorem says, the base angles are angles B and C, and they also happen to be across from those two congruent sides, then what I can conclude is that angle B is congruent to angle C. Oops. And the reason would be the base angles theorem. So if I've got an isosceles triangle, so if two sides of a triangle are congruent, then the angles opposite those sides, so this angle and this angle, which happen to be the base angles, will be congruent to each other, always. That's what the base angles theorem says. Now the converse of the base angles theorem works too. The converse, remember the converse is when you take the original statement and switch the hypothesis and the conclusion. So the converse of the base angles theorem says if two angles of a triangle are congruent, so now we're starting with the angles being congruent, then the opposite sides are congruent. So the sides opposite those are congruent. So then if it's given to you that you've got a triangle with two congruent angles, then by the converse of the base angles theorem, I can say that the sides that are across from those two angles, so the side across from angle C is AB, and the side across from angle B is segment AC, then I can say this side is congruent to this side. So the converse is also true. If you're given two angles congruent in a triangle, then you know the two sides opposite those two angles will be congruent to each other. So these theorems are going to help us. We're not really going to use them in proofs, but they're going to help us solve for angle measures in triangles. Okay, so let's do a couple of examples. So you can take a moment, so you can pause so that you can copy these examples, and then we'll work them out. All right, so on this one, find the measures of angles x and the measure of angle z. So we've got an isosceles triangle, and I know that these two sides are congruent. So then using the base angles theorem, we can conclude that angle x has to be congruent to angle z. So the angles across from those two congruent sides will be congruent to each other. So then that's going to help because I know the vertex angle is 50, and so now I can just do some math to find these angles. Well, what do we know that the three angles in a triangle have to add up to equal? 180. So if I do 180 minus 50, I get 130. That's how much these two have to add up to equal. And so to get each one, since they're congruent, divide by 2, and you get 65 degrees. So the measure of angle x equals 65 degrees, and the measure of angle z has to equal 65 degrees. Okay. All right, then for part B, same kind of concept. The base angles theorem says that if you've got an isosceles triangle where you've got two congruent sides, then I can say the angles opposite those congruent sides are congruent to each other. So that means angle x here and angle z will be congruent to each other. So I can mark those congruent. Well, angle x is x degrees, so angle z will also have to be x degrees. So now let's use triangle sum theorem that we learned in section 4.1 and add up the three angles in a triangle, 3x plus x plus x, and they have to all add up to 180. So combine like terms, 5x equals 180, so then divide it out, and x should equal 36. Now that's not just what they wanted, we have to go back and plug them in and find the angles. So then the measure of angle x is what x was, which is 36, and the measure of angle z equals 36 degrees. Okay, so that's how you're going to have to use the base angles theorem on your homework today. Example 2 is showing how we would use the converse of the base angles theorem. So go ahead and take a moment and copy those down. So pause it, and then we'll start working them out soon. All right, so part A on example 2, notice they gave us these two angles are congruent, and then they listed this side is represented by 2x plus 6, this side is 3x plus 15, and this side is represented by 4x plus 12. Now you cannot add all three of these and set it equal to 180 degrees because side lengths are not measured in degrees. Okay, so don't do that. But this information helps. If I know that these two angles are congruent, I know that two sides of this triangle will be congruent. And so to figure out which sides, I just look across. So the cross from this angle is this side, so this side will be congruent to the side across from this angle, which is this one. So we are not going to use that information. That's extra info. So then if these are congruent, how would I set up my equation? Well, if they're congruent, you set them equal to each other. So 3x plus 15 has to equal 4x plus 12. Now I'm just going to solve. So minus 3x, I get 15 equals x plus 12, minus 12, so x equals 3, and they just wanted the value of x. Okay, so again, remember, side lengths do not add up to equal 180. Only interior angles add up to equal 180 degrees. So then I had to use the congruent angles to know that the sides opposite them will be congruent to each other. Okay, now let's look at part B. And so we have an equilateral triangle. Okay, so up here we learned earlier that if you've got an isosceles triangle, the angles across from them are congruent to each other. Well, what do you think would happen if all three sides are congruent to each other? What could we say about the angles? Well, this angle, so this is a congruent side, so the angle across from it will be congruent to this angle and this angle. So then in an equilateral triangle, not only are all three sides congruent to each other, but all three angles will be congruent to each other. And so then I know this is going to be 2x degrees if that's 2x degrees, and so is this. So now I could set up an equation to solve for x. So for part B, 2x plus 2x plus 2x, all three angles in a triangle add up to 180. Combine like terms, 6x equals 180. So then divide, x is 30. Okay. So just know, make yourself a note that equilateral triangles means that also this is equiangular, which we learned in chapter 1 means all three or 4.1, which means all three angles are going to be congruent to each other. So that's why I made these all 2x, because that was also 2x. Now you also could have done 180 divided by 3 and gotten 60, so you knew each of these angles was 60 degrees, so then you could have just set 2x equal to 60 to solve for x. You still would have gotten the same answer. So either way works. Okay? All right, and I believe, yep, that concludes our notes for today. So your homework for section 4.7 is listed on your tracking sheet, and use the rest of the time to work on that. The answer key is posted on Brightspace. Have a great day.